What is up? Showing my face here. This is what I look like. Let's get started. Got a 3090 Founders Edition today. Pretty impressed by the size of it. I think it's huge. Almost blushed when I saw it. In terms of volume, it's got to be twice the volume of the 3060. So it's big. We ran some benchmarks, some GL Mark, Unengine, as well as the Blender benchmark launcher. So actually, we'll just run them all right now, and I will show you the results of each run. Alright, so I'm just going to show you how to properly install a GPU. First of all, I'm going to assume that you put it inside the machine that you're using correctly, which is definitely the most important step. So double check that your device is actually inside the machine. Boot your computer as normal and see if you can find it using the NVIDIA-SMI command, and it should just show up here. And to see the names, you can do NVIDIA-SMI-L, capital L, and it'll show you each device, and you should see the 3090 as one of the devices. Alright, so head to the CUDA installation guide for Linux. Make sure that your device is capable of running GPU. Make sure that you have the correct kernel headers. Make sure that you install the NVIDIA toolkit. The package installation instructions, this might be the shortest, just doing sudo apt get install CUDA. You've done that, you should see NVIDIA SMI, and you should see your GPU. So you've got your GPU properly. This is the Tesla P100 RIP. Properly inserted into the machine. Now head to your terminal after you boot the computer or able to get to a terminal. If you're on Linux and you cannot boot and you're stuck on a command line, hit Control Alt F2 and that should open up a new terminal. And then you can navigate in the file system with that, as well as do these commands. First, check your NVIDIA SMI, see that you can see the GPUs listed. And then in Python, you can do the same thing. And for both of these, you want to take note of which GPU is which number. Now, if you don't see these, you probably were not able to boot. So if you were not able to boot, if you end up with a terminal, type Control Alt F2, it'll open up a new terminal for you. And you then want to do this, sudo NVIDIA-X config -A. Okay, so now it's created the configuration file and wrote it to this location. And actually what we want to do is sudo nano etc/x11/xorg.com. Boom. So now we're in. You want to make sure that you can see the screens that are displaying. I have 3 options for screen display. And then you want to go down to the device section and look at the devices and look for the board name and see if your board shows up. Alright, so here we are. You should see the NVIDIA SMI and you should be able to see your GPU. Now we look here, we see we have the Xorg all over the place. We don't want the Xorg running on the devices that we want to use for machine learning or doing our training. We only want it running on the GPU that we're using for display, which right now it's trying to use the 3090 as the display GPU. So to change that, we're going to sudo nano into the Xorg config file, which we made using the NVIDIA-xconfig-A command. We're going to take note of what screens are available. There are 3 screens here available, and I'm only using 1 screen. So we want to decide which screen is going to handle what device. So you see that device 0 corresponds to the device 0 up here, and the device 0 is the 3090. So we don't want the 3090 to handle any screen or display. You see that the device 1 is the 9060, which we do want to have handling display, and the device 2 is the 3060, which again we also don't want to have handling any display. So what you want to do is go to each section with a screen and comment these out. So comment out these sections. So you've commented out the sections. Then you want to go up to the devices that you want to use for machine learning, which in my case is device 0 and device 2. You want to add this option. So it's option, use display device, and none. You want to add that to both. I also at the same time added this next under the section. So scroll up to the server layout section, or the section named server layout, and uncomment the auto add GPU false option. Alright, so there's a couple more settings that we should probably take a look at. Render Excel equals false option on the devices that we want to use for CUDA. Okay, and that should be good. One minor thing is on the screen section, you want to change the device to 1, and you want to comment, and you just want to leave this. Alright, so now I'm going to reboot, and I can't show you the reboot process, but when I come back, it should be a lot better. Alright, so Xorg is not going to work with us today, but the devices are, the screens are running on the right device, and I have 4 megabytes or 5 megabytes that are being reserved on every device right now. So you can see that Xorg is running. There's 3 instances of it. It's only taking up 4 gigabytes there, so I will accept it. I got the 3090, 24 gigabytes. Alright, so I'm going to try and retrain the model. I'm going to use the checkpoint that created this beat here. Alright, so we're going to use that checkpoint, and we're going to pass in 2 songs. So for both of these songs, I opened them up in Audacity, I hit Control A, I normalized the sound, and I set the project rate to be equal. In this case, I wanted it to be 48,000, basically, kilohertz. And then I'm going to save these. Actually, I'm going to export them. Okay, so I've exported these files, and I will start the training procedure. For training, let's try, and remember, I'm using this local harmonize, so I had to change the name and the path here. And for settings, I am going to double the sample size to 16. I don't want to increase the batch size. I still want 1 batch to go through at a time. That way, instead of having 2 pieces of audio being trained at the same time, only 1 piece of audio is going to get looked at a time. So we'll leave that, and we'll drop the sample rate from 4820 to 48.1. So that's what it should be. And then we will leave everything else the same. So let's see if it can handle a sample size that's double what it was running before. Let's see how that affects the memory. Okay. Just looking at it, it doesn't look faster, but it is running. So it has handled, and we can see it's on the first batch here. It's not moving faster, but it is working. So and it wouldn't have worked with the 3060. There wouldn't have been enough memory to handle twice the sample rate. So let's see how that turns out. I've already run it once with the sample rate as it was before, so we will be able to check the differences. And I will post that tomorrow.